Hello students, let's come back to the topic we just left and regarding that only we are going to start our new topic of today. The topic we left is power, and related to that we are going to start up the next topic, that is energy. Now this is a very common term in our daily life that we need energy to do work, we need energy to study, we need energy for games, for playing, we need energy to concentrate. Now, this term as we use in our daily life signifies one thing: energy is necessary for each and every single work done. One may ask a question, why when we sleep we don't need energy? Of course, at that time, physically you are not doing any work. But think about one thing, it is not about your doing work. It is about the things which is going on, or the better to say, the processes which are going inside your body. That is the digestion of the food, maybe, because most of the time the people take the dinner after an hour or two, they do their complete their work, and after that it is the end of the day and they are going to sleep. So during that, the burning of the food, the transformation of energy for the next day. In fact, there is a good term that good sleep is also good for your health, for your skin. So all these rejuvenation works are done at night. Now, from the biology part, let's come to physics part. Energy is actually the capability of a body to do the work. Now, anything that can do work, in this case, I will request you to shift from only the living world to everything present over here. That means all those matter that is existing. So, in this case, any particular body which can do a certain work, that means showing certain displacement if force is applied, or showing certain changes, is said to have energy. That means if I say that I am just pushing this box, so whenever I am applying a force, it is showing a certain displacement. This box has energy. So at night, if this box starts walking up by themselves, think that this has energy. What type of energy, we can discuss it later. Okay, jokes apart, coming to the next part, I am on book page number 24, and the point is 2.7, energy as work done. The first line itself says the statement which I mentioned: a body capable of doing work is said to possess energy. So, in this case, let's see that what kind of thing particularly this energy is. Anything that occupies space, possesses weight, and has inertia is called matter. I think this definition you have studied in your earlier classes. Now, any type of matter, 1 minute, two states of matter, the plastic bottle and the tap water inside it. I just keep easier to clean, that's why. So in this case, whenever certain displacements are occurring, the direction is changing, and the level of the water is also showing that. That means that the weight is going down and the level is up for this case. So, this being a different state of matter than this has also shown certain displacement, as you can see every time I turn the bottle. So, that means this is also having certain energy. Of course, what type of energy can water have? For saying that, just do pinhole and check that of course that stream coming out from the bottle will wet your face, and after that you can understand. I suppose this type of experiments you have studied in class 9 regarding the Pascal's law and upthrust and everything. So any body capable of showing the work which is done on it by any means is having energy. There is no transfer of energy if a body is acted upon by a force normal to the direction of the displacement. I am in the note portion of the same page as it is marked with a blue box. When I apply a force normal to the displacement, in this case it is very difficult to show that I will be applying a force and there will be a displacement which both will be in 90 degree, but there are different examples which you have studied already in the portion of work, that is a coolie carrying a load and walking upstairs. Even the coolie, if he carries 20 kgs of luggages of yours and goes to the top floor, you can say, uncle, you have not done any work. But sadly don't say that. He has done the effort of picking up the luggages and carrying it. It's just by the term of physics he has not done, because the angle is becoming 90 degree, and we all know very well cos 90 is a big 0. So the work is not done in this case, because though there is force applied and there has been a displacement from ground floor to the top floor, but at the same time the angle has been 90 degree. So if there is no work done, of course when we calculate it in total, we can see that the body which had the capability to do work at that certain instant when it is forming an angle of 90 degree is not displaying any work. So hence at that condition we just subtract the thought that this particular body has energy. For example, an example is given, it is also very good. A body moving in a circular path, centripetal force is normal to the displacement and hence the work done is 0. Centripetal force and centrifugal force, all these are already explained in the videos earlier. If you at all want to check them again, you can go through the previous videos and check them once. So this is the energy. Energy exists in various forms: heat energy, light energy, sound energy, mechanical energy. So one by one, as we proceed through the chapters, we can talk about different types of energy. Right now let's talk about the main thing, that is units of energy. Since it is only the capability or the capacity to do work, the units of work and energy are same. Now that is only the SI unit, which is joule and erg. But as in every case, when we see or mention about the bigger units of energy, we talk about watt hour, after that it is kilowatt hour, And there is also a different unit of energy which is particularly used for heat energy. In fact, to measure the energy we get from the food also, because it does create certain energy in our body, this unit is used very well. And especially for slight or more fat people like us, this should be a word of consciousness which we don't care at all. That is calories. Full big sized extra cheese chicken pizza has a lots of calories, while a glass of watermelon juice has low calories. So this actually measures the energy which the food gives to us to cause the heat burning capacity and for us to do the work. So this calorie term is mainly used to measure heat energy. Now, whatever I said, let's come to the definitions one by one. Watt hour. 1 watt hour, that means 1 watt into 1 hour. Watt, as we know, is the term or the unit, better to say, for power. Now, work done by time used to be power. So, of course, power into time in reverse will give the work done. And that same thing is used to describe energy. So, 1 watt into 1 hour gives 1 watt hour. Now, as you can see on page number 25, there is an equation written in 2.9. 1 watt into 1 hour, that is 1 joule per second into 1 hour, which is equal to 3600 seconds, gives us 3600 joules, or into 10 to the power minus 3, that is 3.6 kilojoules. Now, for the word kilowatt hour, it is 1 kilowatt into 1 hour. Now, since we already know that 1 watt hour is equal to 3600 joules, multiplied by 10.3, which totally gives us 3.6 into 10 to the power 6 joules, or if we write in one word, it is 3.6 megajoules. All these seem to be that there are so many terms over here, but it is literally because of the term 1 hour is equal to 3600 seconds that all these units are derived from. So once, if there is a problem for you to remember, people like me who had a very bad rote memory can just write them down once. That is 1 watt into 1 hour, so it is 3.6 kilojoule. Again 1 kilowatt into 1 hour, so you can see the number of 10 to the power 3's, and over there you can mention. Since ICSE has deleted quite a number of parts from your syllabus, and we think that will be constant only for the time being, so it is preferred, due to the change of marking scheme, that you don't ignore any part, any detailed term related to any units or anything for the rest of the chapters. Please, as we teachers keep on telling you, read the book thoroughly. Now coming to the definition of calorie. 1 calorie is the heat energy required in raising the temperature of 1 gram of water from 14.5 degrees centigrade to 15.5 degrees centigrade. Now, this change, let's study this term one by one. 1 calorie is the heat energy, we have come to know right now. Now, this, since it is related to heat, is related to temperature, so there has to be certain temperature change which will occur once we just start working. So as a matter of fact, they have taken 1 gram of water for the conventional unit to be built up, and this water has a particular temperature, that is not from 24 degree to 25 degree or 50 degree to 51 degree, but particular from 14.5 degree centigrade to 15.5 degree centigrade. Then whatever the heat energy is required, that particular heat energy is termed as 1 joule. So now there is one more relation which we need to study, that is 1 calorie is equal to 4.18 joule, or round off we can say 4.2 joules. So if we reverse the relation, we can find that 1 joule is equal to 0.24 calorie. Now calorie, of course, itself is the smaller unit of energy, but kilocalorie is the bigger unit of heat energy, because 1 kilocalorie, which is equal to 1000 calories, if we multiply the basic value which we got for 1 calorie into 10 to the power 3, we get it as 4180 joules or 4200 joules. When nothing is mentioned, you please stick to the value of 4.18 joules. If something is given in the question paper, that is 1 calorie equal to 4.2 joules, then only attempt that. The last unit which is mentioned is the electron volt. The energy transfer in case of atomic particles is very small. Atomic particles: proton, neutron, electron. So of course, when it is very small, we need certain smaller units to measure them. That is, 1 electron volt is the energy gained by an electron when it is accelerated through a potential difference of 1 volt. Now, this type of electron acceleration particularly happens in certain labs or particular certain nuclear plants or devices like cyclotron. So when this potential difference of 1 volt is applied, 1 volt potential difference, you can understand if I give the example that those dry cells or the batteries, which we normally say the remote batteries or the batteries used in torches, they are having 1.5 volt of the EMF in them, or that voltage. So if by accelerating a potential difference of 1 volt, whatever energy is gained by the electron, that is termed as 1 electron volt. In short, it is written as 1 eV. Now the charge per electron, as we already know that it is 1.6 into 10 to the power minus 19 coulomb, or the resultant comes as 1 eV is equal to 1.6 into 10 to the power minus 19 joule. So these are the related units of energy. Now energy and power, of course, they are different in many ways. All of them you can write, that is the SI unit, the definition, the formula. So all those will be included. So this much for today. For this definition, we will be coming to the types of energy, whatever required for us, in the next video. So till then, bye bye.